Yeah, thank you very much, Radar. I will take the presentation in English. I hope this is fine for you. Yeah, and I hope you can see my slides now.
Yes.
Okay, great, thank you. So my name is Dimosthenis Peftitsis, and I'm associate professor at the Department of Electric Power Engineering at NTNU. And today I will present a joint work with my colleague Anna Mavroudi from the Department of Education and Lifelong Learning at NTNU. Entitled The Integration of a Student Response System in an Electrical Engineering course. And before starting my presentation, I would like to say that this is a project and a study that was initiated in the frame of one of the UB module courses offered by that department last year. So here's an outline of my presentation. First, I will give a sort of background about the course and I will talk a little bit about the motivation, why I like to integrate the student response system in my course. And then I will present you briefly the design procedure of the SRS, the Student Response System-based activities. I will then present the method that we use to analyze the results, and then I will give you an overview of the most important findings and observations from this study, and I will conclude the presentation with a short summary. So just to give you an idea about the course and the background, the course is called Design of Power Electronic Converters, and it is a course offered at the Department of Electric Power Engineering. It's a 5th year elective course, and I'm the course responsible and the teacher of this course. Last year, because the study that I'm going to present here was conducted a year ago in autumn 2019. And in this autumn semester, the class size was 16. So there were 16 students attending the course, registered and attending the course. And the course is a very technical course, and it is usually organized in 8 modules or topics or themes. That are taught in 12 lectures of 2 hours each approximately. And it is a 3.75 credit course. So it's half of the normal NTNU course. What is the motivation of integrating SRS systems in the course is basically to accomplish one of the main learning objectives, that is to design power electronic systems, which might sound Chinese to you or Greek to you, but it is a very multidisciplinary task if we see it from the pedagogical point of view. And one good way that I believe that can be used to accomplish this objective is to use problem-based teaching and problem-based oriented tasks, where we can combine the various knowledge needed from different disciplines in the course. So basically, as I will show you later on, all these SRS-based quizzes have been designed to be a practical problem in the design field of power electronic systems. Moreover, we, together with Anna, we have thought about how to improve the learner's profile in the course by integrating the SRS activities. And SRS activities or SRS systems is a very easy to use tool to assess previous knowledge. So it can be used basically as a diagnostic tool, as a tool to assess the previous knowledge of the students attending the lecture, and this is one of the ways I use the tool in the course. Moreover, it helps introverted students to be more active and to participate and to get engaged with the course activities and the lectures. It is also a very good tool to provide immediate feedback by conducting post-analysis of the quizzes, and it is also good to switch a good tool or a good way to switch between 2 different means of teaching, for example, slides, traditional slides, and kind of more interactive teaching with and interactive activities. So again, about materializing my motivation of integrating SRS systems in the ELK 20 course is basically the multidisciplinary nature of the course that, as you see on this schematic here, it combines knowledge from different fields, even from mechanical engineering field, for example, thermodynamics or physics, for example, solid state physics, electromagnetic theory, control theory. So as you see, there are different disciplines that needed for the students to understand the concepts that presented in my course. And of course, as already mentioned, I would like to monitor the class dynamics to increase students' understanding, and also and most importantly, to engage students at a higher degree in the course. So the way I designed the SRS-based activities, before doing that, I had a look at the revised Bloom's taxonomy, and I tried to map the basic and the advanced course in power electronics. So what I'm talking about in this presentation is an advanced power electronics course. It is offered in the 5th year. However, there's also a basic course in the field of power electronics that is usually given in the 3rd or in the 4th year. So the basic course, with the basic course that I'm also responsible for, I try to actually target the 4 bottom levels in the revised Bloom's taxonomy. But with the advanced power electronics course, my goal is to design activities in order to reach the 3 top levels in the revised Bloom's taxonomy. And this is the starting point where I started and start designing the SRS-based activities for the course. And the idea of the course is actually to enable students to create and to develop competence in the design of power electronic systems. So they should actually work with in-class activities that target the 3 top layers, namely analyzing, evaluating, and creating concepts and systems of power electronics. So this slide shows how I implemented the quizzes and how often I presented the quiz in class. So first of all, I use multiple choice questions for this in-class SRS-based quizzes. And each of these multiple choice questions had 4 or 5 options. The frequency of the quizzes in a 2-hour lecture, I usually presented 4 to 5 on average, 4 to 5 quizzes. And of course, always I started with a diagnostic quiz at the beginning of the lecture in order to link the material and the theories that I presented in the previous lecture with the ongoing lecture, and to also make the students aware of what we are going to talk about in the current lecture, and also to make the students able to link the concepts between 2 individual lectures. And then a special focus was put on designing the alternative answers. So how I designed the 4 or 5 options. I always had 1 correct, obviously, or 1 very correct, 1 obviously wrong, that it was wrong at the first sight, and 2 or 3 almost correct or almost wrong answers, in order to make the students think a little bit and trigger their critical thinking and so on. And after the students responded, I always carried a post analysis of each quiz. And at the end of the lecture, I also carried a post-lecture reflection question about their feeling and their understanding of each specific lecture. So now I will give you 2 examples of these questions and the answering pattern of 2 questions. I just grabbed those 2 questions because if you see the figure on the left-hand side of the slide, in that figure, you see 5 alternative answers. one is very correct or the correct one, and there are two almost wrong or almost correct and two wrong. And as you see, in this case, the students, most of the students replied the correct answer, that is option D. So the majority of the students replied that one. And in that case, I always started the post-analysis from the most wrong alternative in order to gradually develop the concepts and theory and explanations and analysis and reach the correct alternative, the correct option. On the other hand, if you see the right-hand side figure, in that case, the majority answered wrongly. So the majority of the students answered option B. The correct one was option C. And in that case, I started the post-analysis in class from the option that received most of the votes. And in that case, it was option B, and explained towards the correct one. So I will move on to the methodology that we used and we developed together with Anna. Again, there are 16 students participating in this study, 2 females and 14 males. And they come from various study programs, including the 5-year integrated master program in energy and environment, the 2-year international master program, as well as various Erasmus programs, which means exchange students. And the average age of participants was 23 years old. Then for data collection, we had 2 types of data that we collected: the quantitative data that are basically responses to the quizzes and statistical data from how the students responded, and qualitative data from interviews that were carried with all students. And through these interviews, we try to find common patterns on, for example, student experiences using the SRS systems in class, classroom dynamics, engagement of students, motivation or demotivation of students, learning and understanding of concepts. And now I will present some results. So first, and one of the results that received massive attention and massive responses from the students is the student attention. So if you read here, most of the students said that the clickers or the SRS system helped them to sustain attention, to be more focused, to concentrate on the lecture. And here you see some of the typical excerpts from the interviews. For example, students say that they are more awake and they could follow the lectures better, and they paid attention to what the lecturer said and presented, and so on. And this is something that we already expected, that the attention of the students will increase. The second observation was the immediate feedback, and students received immediate feedback, as I already discussed in a couple of slides ago, that the post-analysis of the quizzes was carried out almost after the students responded to the multiple choice questions. And this feedback does not only reveal the correct answer, but also explains and justifies why the other answers, the other options are not correct. And I think the students really like this, because they get immediate feedback on their answers, and this also increases understanding of the concepts, and of course understanding of their own mistakes if they have answered wrongly. The students also appreciated anonymity, because in comparison and in contrast to other SRS systems, in this case we used an SRS system tool that enables anonymity. So the students reply, but their names or nicknames do not show up on the slide. So they they can freely choose the option without being afraid of their name showing next to a wrong answer. And students really like this because they felt more comfortable when answering questions, and of course they felt also more comfortable because their fellow students couldn't really understand or realize who has voted correctly or wrongly. The fourth observation is a little bit more course-oriented, and it is the way that the questions were built. And most of the students said that the questions were very appropriate for the course, very technical and very relevant to the course, to the theory presented in the lectures. They were small and also important for the course. Because they also pointed out that within the questions, the lecturer tried to basically present the take-home message from each lecture, which was really good for students to identify immediately which topics of the lecture are important to focus, and also are important and very likely to appear in the exam later on. And the last observation is related to students' motivation, and this is basically this has two sides. One is that, of course, students feel more motivated because they are more engaged, and because they have something to expect during the lecture, have to expect a quiz to answer. But using an SRS system in the class might also contribute to demotivation of the students, because when the student answers wrongly, then the feeling is that this student is more frustrated. And this is something that a few students pointed out during the interviews, especially students answering wrongly in a row of 3 or 4 or more questions. Yes, and I will conclude now my presentation. So again, the aim of our study is to understand students' perceptions on using an SRS-based system and SRS-based quizzes in an advanced technical engineering power electronics course. And the themes mentioned by the students in their interviews and what they feel is important, and what they feel that they gain by using an SRS system in the course is increased attention, possibility to get immediate instructional feedback on different problems and questions. They appreciate the anonymity of the answers, and they also like the way the questions were developed and were presented. And also regarding motivation, there are two options or two sides. Most of the students felt motivated, but there were also students that might have felt demotivated at some specific points of the lecture and the course. And the importance of using SRS along with the subject matter questions once again verifies the alignment of using educational technology for improving and for enhancing understanding. And this is something that was also appreciated by the students, as we have seen through this study. So thank you very much for your attention, and I'm glad to answer your questions.